So now we're going to discuss about multiple access links and protocols. Now there are two types of links. One is point to point and you have broadcast. Point to point is one to one and broadcast is one to many. So you have diagrammatic representations to them. So now we're going to talk about multiple access links and protocols. There are two types of links generally. You can say it's a point to point. Or else you can have broadcast. So point to point is one to one and broadcast is one to many. And you have different examples that is over there. And in broadcast you have 802.11 that is coming over. Now to support all these things, you need to have multiple access protocols because you just say that more than one person is trying to communicate. So we need to have multiple access protocols to do that. So that in a way that you're going to reduce collisions and all those requests. And all those things would require to access your data rate. So if only one person is there, your rate, if the channel capacity is C or your rate is R, you'll be getting the whole. And if you have two persons, it will be R by 2 or C by 2. If there are M, you will be basically dividing that whole thing into M different people. So that is what will be defined over here. Now, the different structures that you have for this is divided into three basic classes. One is channel partitioning. Second one is random access and taking turns. So these are three different ways by which we can achieve multiple access. So the first part you guys already know basically. So we'll go through that. The second one is basically random and third one is taking turns. Now, channel partitioning in terms of this particular definition is basically the first one is TDMA, time division multiple access. So you have a particular slot and it is being divided, or you have a frame that is divided into different slots. So you have 1, 2, 3, 4, 5, 6. So this is basically fixed. Now, just say that you have a 6-slot structure, your full time is divided into 6 slots. So at the first slot, what you see is that, or first frame, what you see is that only the first channel has something to transmit, third has something to transmit, the fourth has something to transmit, and the others are blank. So these slots are basically free because you say that the time slots are fixed, just like your timetable. Now you have 4 hours, and the 4 hours is where just say that our 4 subjects, and one day I don't come. Just say that you have 2 hours for that. So basically you have wasted 2 hours, and the other 2 hours you have. So that is what is happening here. So you have a bandwidth or a capacity, and you see that is wasted over here. And at second frame, what you see is the same thing that comes over here. So slots 2, 5, and 6 are ideal. The next one is basically you have to ensure that no such thing doesn't happen in terms of time slot. So here, what happens is that the whole bandwidth is given to 2, but it is wasted. The whole bandwidth is given to 5 and 6 is wasted. Only 1 and 3 are replacing it. Now what you do is that now you divide that in terms of frequency. So there you have frequency division, multiple access. So the whole thing is divided into different bands. So the first channel is given one band, the second is given the second, third, fourth, fifth, and sixth. Again, what you see is that again here only 1, 3, and 4 bands are being used. Again, the other 2, 5, and 6 are not being used. But you're not wasting the whole band, but still part of it is being wasted because it is staying there idly. So you have another version so that in terms of CDMA and all those things that is coming for the time being, we can stop with this. Or if you want to look forward one step further, you can have 4 division multiple access also. The next topic, next version to that is random access protocols. In that, you have 2 or basically more than 2 versions. The pure ones are the first basic one you have Aloha, then you have slotted Aloha, and then you have CSMA and its variants CSMA CD and CSMA CA. CSMA stands for Carrier Sense Multiple Access. This stands for Carrier Sense Multiple Access with collision detection. And you have Carrier Sense Multiple Access with collision avoidance. So you have these are all random access protocols. If some questions ask for what are different random access protocols, you can mention all these things. Now, what is unslotted or just pure Aloha or just Aloha? What you have is that if basically you say that there's no synchronization between all your communications, there's no fixed times across all these stations. So you can see that this is time t is equal to 0. Now you have time t is equal to, so time t is equal to t0 plus 1, and this is t0 minus 1, a time prior to it. So at time t is equal to 0, there was somebody who is transmitting. So what you see is that a previous transmission, a frame is there. At time t is equal to 0, this one node tries to transmit. And at time t is equal to t0 plus 1, another node is trying to transmit. So what you see is that since these frames overlap, the green frame is lost because it is being it is colliding with this yellow colored frame. And even this yellow color frame is lost because it is coinciding or colliding with this particular purple color. So since there is overlap, you can say that at the end, at this particular point, what you say is that neither of all these frames are correctly received. You have to retransmit it. So even though this is the most simplest of it, there is no time synchronization and all those things. The probability of collisions, the probability of data loss is high over here. Now you can go with a slotted aloha. That is an improvement to that. This is an example to that. Okay. So from the name itself, before you didn't have any slots. Now we are dividing that into different slots. So you say that the 3 nodes want to transmit. So there are different slots. So the time frames are fixed. So at say, and all these things are basically, you can say that you can label that as time t is equal to 1, 2, 3, and all those things. You say that. So at time t is equal to 1, you say that node 1 is transmitting, node 2 is transmitting, node 3 is transmitting together. So we can assume that all 3 are lost. So all 3 collided and nothing went through. So some random waiting time. And at that time, what happens is that node 1, after some time, node 1 and node 2 randomly started to retransmit. So at that time, again, 2 people are there in this network, 2 frames are there. Again, there is collision. So this is also lost. This is lost as well as this is also lost. Now, after some time, what happens is that after that, some time, what happens is that node 2 transmits. And you see that node 3 and node 1 is not transmitting. So this is successful. After some time, again, what happens is that node 1 and node 3 simultaneously try to transmit. So again, collisions. So it again waits randomly, and at a particular time, node 1 transmits. At that time, nobody is there, so it's successful. And after some time, node 3 transmits. Again, since nobody is there, it is successfully transmitted. So what difference is there with Pure is that this is synchronized. A common clock is followed by all. And if there is collisions, the third packet is lost. There is random waiting time, and after random waiting time, what you see is that each of them transmits, and if there is again 2 transmissions coming simultaneously, then there is collisions, and we are trying to come across that. Now, in terms of performance, the pure aloha, this is one thing that you can note. The pure aloha, the efficiency is just 0.18, or in just you're transmitting 100 packets, only 18 packets will be, or 18 frames will be successfully transmitted. Whereas in terms of slotted aloha, this is double of that. So for every 100 frames, you can say that approximately 37 frames are successfully received, but even it's too less. So this is the efficiency comparisons between slotted and pure aloha. Now the next random access protocol is basically carrier sends multiple access. Listen before you transmit. That is a basic logic behind it. So basic logic is basically you sense whether somebody is using it. If somebody is using it, you differ, and then and after it is free, you transmit. Just like when I am talking, you say that yeah, somebody else is talking, so you stay back. Now, if the channel is free, you just say yeah, whatever you have in mind. So that's basic logic. Now, improvisation to that is basically CSMA with collision detection. Now, what do you do when collision is there? Do you keep on transmitting? Just say that no, you're trying to do something, and at a particular point of time, you observe that it went wrong. So there's no point in continuing, right? So pure CSMA, even after the collision is detected, that particular process continues. Now, with CD, what happens is that once you detect it, the transmission stops and it sends a jamming signal. So this is a pictorial representation of what is happening in terms of CSMA. So what you see is A, B, C, and D are different nodes that you want to transmit. So you can, as you see that no B is transmitting. So this shows that at T is equal to 0, B is transmitting, and after some point of time, so if it sees that no, if you check if the channel is free or not. So at this particular point, B senses that there is nobody transmitting, right? So it transmits. And its transmission goes in all directions. Now at T is equal to T1, at this particular point of time, you see that no, B's energy did not reach here. B's energy reaches here only at this particular point, right? So at this particular point, D doesn't know that no, B is transmitting. So at that time, even this particular point of time, you say that D's transmission is only till here, right? So D doesn't know it. So what D senses that there's nobody transmitting, so it transmits. So D's transmission starts. So at this particular point of time, they both collide. The informations collide. But even after collision, B continues transmission till whatever it needs to transmit, and D continues its transmission till its transmission continues. So CSMA is satisfied. They both started their transmissions at this particular point and at this particular point by sensing that there's nobody there. But even then, there was collisions. Now, CSMA CD just says that no, once there is collision that is detected, now you say that again the same principle, T0, D started, T1, say D started. Now, once there is collisions, what they do is that they abort. You see that they don't go for it, the full transmission, they just abort. At this particular point, they stop their transmissions and they don't continue. So you're just saving on your bandwidth. And just not just abort, then they'll send a jamming signal saying that there is collision, so everybody stay back, so that none of them will be having an issue, and they will stay back for some in the frame space IFS, and then it just they can start after that. So this is what is CSMA with CD. What to do after collisions. Now the next one is in terms of what you say in random access is not random access. Multiple access schemes is taking turns. So taking turns basically is saying that the best of all worlds. That is what the statement that says over here. The most simplest of it is polling. Now the teacher asks if somebody wants to say something. So the first person raises hand and says, "I want to say something." And it transmits, and there's no issues there. Again, it polls, and they say that third person wants to send something, raises hand, and it transmits. So at no point of time there will be collisions, and you can say that it is the best reliable structure that is there. And another one is basically token passing in this particular structure. A token, if you want to transmit something, you need to have a token. So you see that the token is being originating and it is going to the first person and it doesn't have anything to transmit. So what does it? It just forwards the token. Here, this particular fellow has something to transmit. It transmits the data, and finally the data comes back to the source and it is taken off of the network. But still the main takeaway from this is that if you want to transmit something, a token is being passed to the network. And once you have a token, then you transmit. CSMA, in terms of random access, there is one more protocol that is CSMA CA. And this we have discussed in another video when you're talking about 802.11, the access protocols. Okay, you can refer to that also. So these are the basic steps in terms of multiple access protocols. Thank you.